Hello guys, welcome back to my channel Algorithm Minds. My name is Hasan Khurram, and in this channel I teach programming skills in Python, MATLAB and R programming. And I also teach statistical concepts, theoretical concepts as well as practical programming skills in data science and data analysis. So if you're a person who wants to learn Python from beginning or even R or MATLAB, or you want to learn and excel the domain of data science, I suggest you to subscribe to my channel, hit the notification bell icon button. As I have discussed earlier, I am going to produce a series of videos on the topic of statistical analysis in Python. So in today's lecture, we are going to discuss about statistical analysis, and particularly we are going to discuss about the fundamental concept here, which is descriptive statics and central tendency. So to give you an idea about descriptive statics are a set of techniques used to describe and summarize the features of our data sets. They provide insights into the central tendency, variability and distribution of the data. In this tutorial, we will cover two fundamental concepts of descriptive statics: measure of central tendency and measure of variability. So these are two important concepts in descriptive statics, and I'm going to explain you about the measure of central tendency in this video. The measure of central tendency are statistics that represent the center or middle of the data sets. The three main measures of central tendency are the mean, median and mode. They actually help us identify what is the center or middle of the data sets. So, and we are going to actually calculate that measure of central tendency by the use of Python programming. So in order to do that, we are going to first import our library NumPy by using this Python statement here. Import NumPy as NumPy, where NumPy is a library and as NP is an alias. For example, whenever you want to actually call the library in Python environment, you will use NP instead of NumPy, so it's called alias. Now, once we have declared our library or imported our library, we are going to declare our data sets. So I have written two data. For in this purpose, I'm going to declare a NumPy array that has a number of elements in it, and the elements are not in order. They are distributed randomly. Randomly in sense in that it's not statistically randomly distributed, but I have just taken some randomly elements are in it. So this is my data here. In order to declare a NumPy array, I'm going to first initialize a variable named data. Then I'm going to pass a value by calling NumPy class np.array, and then I'm going to declare a list within the method here, and that will actually convert that list into a NumPy array. So we have like elements 10, 30, 70, 110, 70, 170 and so on. And I also written a sorted list, so you can actually get an idea what does this element or list represents in the form of sorted, like when they are sorted, how they are represented. So let me just run this block of code for you, and also let us visualize that. By using print function to display those two NumPy arrays in console or written output. So now you have printed our data, which is a NumPy array, and it has elements in it, and also printed sorted data, which is again the same array but with the values that are being sorted. But we will perform all the operation on the data NumPy array. So once you have done that, now we can actually perform our calculation. You know that we recall that we actually want to calculate the measure of central tendency, and we have mean, median and mode. So first of all, let's discuss about mean. The mean is actually calculated by summing up all the values in the data sets and then divided by the total number of values, and it's sensitive to outliers. What is an outlier? So outlier is something that an element in an array that is actually exaggerated in terms of its quantity. For example, we can actually say that the 500 in our case is actually an outlier, because the maximum we do see in our data set is somewhere around like 190, 200. So in that context, it should be somewhere around 210, 230, but 500 seems to be an outlier. But so whenever this outlier is presented in the data, it will create an error, or not create an error, but it will affect the mean of the data set or a NumPy array. So in order to calculate the mean of a NumPy array, we are going to call the NumPy library by using alias np dot, and then I'm going to call its method mean, and then within that round brackets I'm going to pass data as input argument. So in order to calculate the mean of the NumPy array, I'm going to use the library np, then I'm going to call its method mean, and within those round brackets I'm going to pass the input argument, which is our defined NumPy array, which is data. And once I done that, I am able to actually extract the mean out of that data. And then after I have calculated the mean, I'm going to use this Python statement which uses print function, and within those print function it uses fstring method, which allows us to embed variables within a string dynamically. So and the approach to actually do it is actually we first write f, then we put quotation mark, then we write whatever the string we want to write, and for the variable we actually want to embed in that string, we are going to define within curly braces. So you can see that I have defined mean value within curly braces. Lastly, I have used this colon dot 2f, which is actually helpful to set what is actually up to what decimal points we want the result to be displayed. In that case we have used 2f. It means that up to the 2 decimal points we want the result to be displayed, and after that rounded up to the according to the mathematical operations. So this is what actually 2f dot mean. So colon dot 2f is actually an additional parameter we are defining here, and that is actually help us to display the result for our desired number of decimal points. So let me just run this block of code over you. Now you see that we actually do get a mean that is equal to 132.31. So this is actually the mean of our NumPy array data. Now let's move on and actually discuss about median. So the median is the middle value of the data set when it is ordered from the least to greatest. It is less affected by outliers compared to the mean. So if you recall that we have this sorted data set here, which has like 10, 30, 50. So when we arrange this data set in this form from the least to greatest, so the median is actually the middle value of our data set, and it is less likely to be affected by the outliers. For example, in our case we said that 500 could be an outlier. So in that case it is less affected by the outlier because it depends on the quantity of where the middle value is represented. So it's less likely to be affected by 500. For example, if instead of 500 we have like 230 or 250, still the median will be the same quantity, so it's less likely to be affected by an outlier. So in order to calculate the median, we are going to use the same thing. I'm going to initialize a variable name, then I'm going to assign its value by calling the np library, NumPy library, by using alias np. Then I'm going to call its method median, and within those round brackets I'm going to pass input argument or data, which is a NumPy array. Once I have done that, I'm going to print this value by using the same print function, and within print function I'm using fstring method. So when I done that, you see that actually the median value is actually 90. Now let's move on and actually discuss about how we can actually calculate the mode in Python programming. For this purpose, I'm going to initialize a variable named mode underscore value. Then I'm going to create some value to it by calling NumPy library. We have this function method here np argmax, but let's not more focus right now. Np bit count data, which I'm calling the method bin count, and I'm passing the input argument our NumPy array. So it will actually return a list of occurrences of the values that were actually present in our NumPy library. So for example, it will for example, let's take an example. Let's say we have a NumPy array that has values of 0, 1 and 2 and 3 and 4, where 3 is actually repeated 3 times, 2 is repeated 2 times, and 1 is repeated only 1 time, and 0 it doesn't occur at all. So when we pass this NumPy array to this function named np.bin count, it will actually return us the number of occurrences, and those occurrences actually are indexed by the number of values that are actually present in the original NumPy list. Okay, for example, it will return us 0, 1, 2, 3. In that case, we know that 0 occurred 0 time, where 1, how many times it occurs? It occurred only 1 time, so we have only 1 as an output from this method. Then how many times the 2 has occurred? So the 2 has occurred 2 times, so we will have 0, 1 and 2 in the index, second index. So it will present that 2 has been occurred 2 times. So it gives us a list of the number of occurrences, where the number of occurrences are in correspondence with reference with the actual values. For example, 3 we have, which is occurred 3 times, so in that case the output, the 3 will be like 0, 1, 2, 3. So that's how it actually works. Then we have this function here np.argmax that will actually calculate the index of the maximum occurrence. Okay, for example, in our case, if 3 has occurred maximum time, so it will take a look at the index where it actually 3 lies in that list, and it will calculate the maximum the index of the maximum occurrence of that specific list. So it will take the maximum index of maximum value, and that's how you are able to calculate the mode value by using this Python statement. So once I have calculated the Python statement, I'm going to use the print function, and with the fstring method, let me just run this block of code for you. So now you can see that we have actually extracted mode, which is the most repeated value in our data set. So we have actually discussed briefly about the measure of central tendency in this tutorial, which is actually one of the most important aspect of descriptive statistics. The next important descriptive statistics concept is the measure of variability. Okay, so what is that measure of variability? The measure of variability describe the separateness or dispersions of the data point, how actually the data is distributed or separated. These are the two main measures of variability are range and standard deviation. So the measure of variability or statistical dispersion, this is something I have actually discussed in detail in a separate video. So I will put the link in the description for you, so you can actually go and watch that video. So it's a highly resourceful video. That's it for this tutorial. Thank you for joining me, and stay tuned and hit the notification bell icon button, because I soon will be posting more videos related to statistical analysis in Python. Thank you.